Hello and welcome back to Study with Khan. We'll start from where we left off last time. Our topic is ionization energy. It is defined as the energy required, which means it's an endothermic process. Endothermic process. To remove the most loosely held electron from 1 mole of gaseous ion to form 1 mole of gaseous unipositive ion. The equation for the first ionization energy is X gaseous. It becomes X positive gaseous monopositive ion by the loss of 1 electron. Next, we'll do trend of ionization energy across the period. We have already done trends across the group, down the group. You can watch it in the previous video. Now let's do trend of ionization energy down the group. Generally the first ionization, we're talking about the first ionization energy increases across the period. What's the general trend? The general trend is that the first ionization energy generally increases across the period, with 2 exceptions. Ionization energy depends upon a few things. Ionization energy depends upon, number 1, nuclear charge, which is number of protons inside the nucleus. Secondly, it depends on number of valence shell electrons as well as the electronic configuration. Valence electrons are, as I've already mentioned before, valence electrons are the outer shell electrons, the outermost electrons. So yeah, iske baad, it also depends on the shielding effect. What's shielding effect? Shielding effect is decrease in attraction between the nucleus and the valence electrons due to the presence of inner shell electrons. अच्छा, इसके 2 ट्रेंड्स है, शील्डिंग इफेक्ट और स्क्रीनिंग इफेक्ट. Shielding or screening effect remains constant across the period. Why does it remain constant? It remains constant across the period because electrons are being removed from the same shell. Whereas shielding effect increases down the group because an extra shell of electrons is added to each element when we are going down the group. इसके अलावा ionization energy also depends on the ionization energy also depends on the atomic radius. Okay, so moving across the period from left to right, nuclear charge increases by 1. For example, in period number 3, sodium has 11 protons, whereas magnesium has 12 protons, aluminium has 13 protons, whereas silicon has 14 protons, phosphorus has 15, sulfur has 16, chlorine has 17. So the nuclear charge increases by 1, whereas number of valence shell electrons also increases by 1. As a result, attractions between nucleus and valence shell electrons increases. The nucleus pulls the electrons more closer, and so atomic radius or the distance between nucleus and valence shell electrons decreases. As a result of these factors, because the attraction between the nucleus and the electron increases, and so the first ionization energy increases across the period. Achha, now let's talk about exceptions. We have 2 exceptions. The first exception is between in period number 3. In period 3, the first exception is between in period 3, the first exception is between magnesium and aluminium. Let's talk about the electronic configurations of both magnesium and aluminium. Magnesium has 12 protons, whereas aluminium has 13 protons. Let's write the electronic configurations of both magnesium and aluminium. Magnesium has 12 electrons, so its electronic configuration is 1s2, 2s2, 2p6, and then 3s2. Whereas in aluminium, the aluminium has 13 electrons, and so its electronic configuration is 1s2, 2s2, 2p6, 3s2, and 3p1. Okay. In magnesium, the valence shell electron is present in the third shell. 3 denotes principal quantum number. 3 denotes the value of principal quantum number. And in magnesium, the electron is being removed from the third principal quantum, and it's present in an s subshell or s orbital. Whereas in aluminium, the valence shell electron is present in the third quantum number, but the valence electron is being removed from a p subshell. It's being removed from a p subshell. Okay, so generally s subshell is present more close to the nucleus, and so electrons in an s subshell are more strongly attracted by the nucleus, and so it's difficult to remove an electron from 3s as compared to 3p. 3p subshell is present further away from the nucleus and so is not as strongly attracted. As a result, the first ionization energy of magnesium is higher than that of एल्यूमिनियम. रीज़न क्या है? रीज़न यही है कि हमारे पास जो मैग्नीशियम में इलेक्ट्रॉन इज बीइंग रिमूव फ्रॉम 3s, whereas in aluminium the electron is being removed from 3p. हमारे पास ऐसे होता है कि 3s subshell जो है it's present more close to the nucleus. सही है? 3s subshell is present more close to the nucleus and so the electron in 3s is more strongly attracted by the nucleus, whereas 3p is present further away from the nucleus and so it's not as strongly attracted. वैसे तो जनरली तो यही है कि ionization energy increases across the period, but magnesium has a first higher ionization energy than aluminium. And रीज़न आपने इलेक्ट्रॉनिक कन्फिगरेशन में देख लिया होगा, मैग्नीशियम का इलेक्ट्रॉन इज बीइंग रिमूव फ्रॉम 3s, whereas in aluminium the electron is being removed from 3p. As 3s is more closer to the nucleus, so the first ionization energy of magnesium is higher than that of aluminium. Next, अच्छा एक और बात, period 2 elements, no, group 2 elements. Group 2 elements have a higher first ionization energy than group 3 elements. अभी फॉर एग्जांपल ग्रुप 2 के कौन कौन से एलिमेंट्स है? बेरिलियम, मैग्नीशियम, कैल्शियम, स्ट्रॉन्शियम, बेरियम एंड रेडियम. ग्रुप पीरियड एल्यूमिनियम. तो अभी जितने भी ग्रुप 3 एलिमेंट्स है, ग्रुप 2 एलिमेंट्स है, ग्रुप 2 एलिमेंट्स विल